Well, I'm Luis Lopez. I'm going to present this work.
Okay.
Well, my name is Alejandro Lopez-Agudo. I'm going to present this work, which has been performed together with Oscar David Marcenaro Gutierrez. We are both from the University of Malaga, and it is entitled Spanish Students' Achievement and the Instruction Time. Well, as you know, Spanish students spend many hours at school every day and every week. Um, this kind of high amount of instruction time is usually based on this conception of the more time you spend in something, the better you get on this thing that you are doing. But a potential problem could be that this time that students are spending at school may not be directly transformed into academic achievement. And this is what we want to explore in this research. So according to a recent report, Spanish students spend around 1,000 hours at school in 1 year of compulsory secondary education. There are only few countries which surpass this amount of hours, like Latin American countries such as Colombia, Mexico, Costa Rica, and Chile, for example. The problem with this is, okay, we have many hours, but well, if they are transformed into higher academic achievement, well, things are okay, and we agree with this kind of policy of instruction time. But the main issue is that Spanish students perform 477 points in reading and 481 points in mathematics in the last PISA cycle, and compared to other countries like, for instance, Ireland, in which students receive a lower amount of instruction hours in compulsory secondary education and perform higher. For another example is Slovenia, in which students spend almost 300 hours less than Spanish students, and they perform much higher. So, well, these are descriptive statistics, but we could be thinking at this time that maybe there's something happening here, because if all countries have the same productivity in the instruction time, then students should perform higher, and this doesn't seem to be the case. So in this context, we intend to explore this kind of relationship between instruction time and academic performance for the Spanish case. And in order to do this, we use PISA data, the most recent PISA cycle, which is based on 15-year-old students. We intend to go further from correlation and try to approach a causal inference. So as I said before, the data that we are using is PISA from its last cycle, 2018. 15-year-old students are those who are assessed, and they are assessed in reading, mathematics, and science. And we are assessing competencies in PISA. This is very important. Competencies are skills, not content-based knowledge. These are not contests, but abilities, the capacities that students have to perform some kind of task. PISA is intended on 10th grade students unless they have repeated, because it is focused on 15-year-old students, so they have to be in 10th grade. But they can be in a lower grade if they have repeated. Well, the most important part of this research study is that we have two questions which let us calculate the time that students spend at school every week and in each subject. So we can know how much time students spend in reading, in mathematics, and science. And we also know their competencies in the three subjects. In particular, these questions are how many hours per week are you typically required to attend to the following subjects? And in a normal full week, how many are you required? Well, this is referred to hours. So we can know how many classes students have in a week of a particular subject and how many hours are they spending in each class. So we can calculate weekly instruction time. These are the variables that summarize this weekly instruction time in PISA for reading and mathematics. We are focusing on reading and mathematics only. So the next step is to create an approach that let us get to causality more than correlation. And this is done using student fixed effects. In particular, in this model, we have a dependent variable, which is student scores. Student scores are calculated using the actual responses that the students made in each questionnaire, because maybe, as you may know, in PISA students do not answer all the questions. They answer some questions, and then PISA use a multiple imputation system in order to impute the questions that the students haven't answered. So in our dependent variable, we use the actual responses. So which questions actually students respond for reading and mathematics. Then we have the instruction time variable, which is measured also for reading and mathematics, controlled by subject, reading or mathematics, student observable characteristics, and school observable characteristics. And as we are using student fixed effects by subject, so we have within a student between subjects, we can take differences, like here, differences between subjects, and then remove everything which is similar between subjects. This is student observable characteristics are the same between subjects because students, for instance, are female in reading and in mathematics. So this variable is not necessary to be controlled and it can be removed. And this also happens with school characteristics. Those which are similar between subjects, this is all the school characteristics, can be also removed. And we are left with the instruction time variable, which is a variable that changes between subjects, between reading and mathematics, and also student competencies in reading and mathematics changes. So thanks to this specification, we can control by unobservable variables that are similar between subjects, but we don't have in our database. And in this way, we approach a causal inference. We have a very important assumption, that is that the productivity that the education production function of students for their instruction time is the same for reading and mathematics. This is, students take the same advantage of instruction time in reading and the same advantage in mathematics. This is the strongest assumption that we are doing here, and it's an untestable assumption because we don't have any data about this. That's the only strong assumption that we have. In this research, we performed a test suggested by Mesler and Wasman, which intends to check this equality, and we obtained that both subjects have an equal productivity. So, well, we cannot be 100% sure, but we have checked with this, and we can be a little more confident about our results. This is these are the main results. So we have these are previous models by ordinary least squares for comparison purposes, and we have a model for reading and a model for mathematics. If we did this mistake and use ordinary least squares, we can see that instruction time, 1 hour of instruction time, seems to reduce students' performance in reading in 0.1 standard deviation and 0.02 standard deviations in mathematics. But the thing is that, as I said before, these two estimations have many unobservable variables which are not controlled in our model. So these coefficients would be the result of variable omission more than an actual effect. So we move to our fixed effect model, which is our preferred estimation, and we obtain that instruction time doesn't seem to have an influence on students' performance, which is a striking result. And we will comment on this in the conclusions. These results have been checked using other approaches like plausible values. Plausible values are the imputed skills that I told you before. We are using in our model we are using the actual responses to the test, but PISA calculates plausible values which are imputed from these imputations of these answers. So there are some questions that the student didn't answer, but they have imputed the potential answers. Well, we use this, which is created by PISA, and we obtain similar results. And we also average instruction time by school in order to reduce in certain way the potential bias that the students can have when they report their instruction time, because maybe students are asked how many hours spent in each class, and maybe they make some kind of misreport. And also in the case of weekly classes, so we average by school in order to get a more general measure of this instruction time, and try to remove as much as possible this report bias. And results did not change. We obtain a null influence. So this is an striking result, and we try to say, okay, why are we getting this? Well, the thing is that Spanish education is, as previous literature has reported, is strongly based on content-based knowledge. Content-based knowledge is like learning by heart. This is students learn how to solve certain kind of problems, and then in the exams they are asked this kind of problems with numbers, different numbers, or different. In the case of reading, maybe different sentences in which they have to analyze, for instance. So students are learning mechanical tasks at the schools. However, what PISA is measuring are student competencies and skills. This is students' capabilities to approach a new problem and solve it. And maybe what we are seeing here is that the weekly instruction time that the students are receiving is unproductive in terms of competencies. So, okay, students are passing their exams, they are learning how to do this mechanical task, and they go on with the information, but they are not improving their skills. This is the competence that they have to approach a new problem and solve it. So this is also increased by this attitude by parents. So maybe parents know this. Sometimes they don't care because this high amount of instruction time is used by them usually as a kindergarten service. So they say, okay, well, my children is learning, I think the children are learning, and also they are having their children being taken care at school. So they don't, if they are working, well, they are not concerned so much about this excessive instruction time that the students are receiving, because they have their children at school and they can work and then take them at home at the evening, in the evening, for instance. But what can we propose to solve this? Well, the first thing is to approach education from a competence base, which is not easy, but there are some approaches in the literature which teach how to do this. And also, if students are receiving this kind of unproductive weekly instruction time, maybe they could change this kind of excessive amount of time to activities which are different from their subjects, and they can learn other competencies. For instance, extracurricular activities, for instance, arts, music, even oratory or something which let them improve other competence. So what we propose is a better use of this instruction time in a competence way, and also if students are receiving this kind of excessive amount of instruction time and unproductive, this could be moved to other kind of activities which could improve students' competencies in other fields. That's all. And thank you very much for your attention. And if you have any question, I will be very pleased to answer them.
Thank you very much, Luis Alejandro. Thank you very much for your presentation. I think it has been quite illustrating also how this PISA data can be used also to understand what is going on inside the schools. Meanwhile, somebody wants to make some questions, you can raise your hand and you can open then the microphone and make your question live, or write it in the chat as you prefer. I would like to thank you again for your presentation. There is a study from the OECD from some years ago that Sandra and me, we commented on the Guía de Tiempos Escolares we wrote some years ago. Also was about this phenomenon of the amount of hours, the instruction time, and they have quite an interesting also frame to understand also how much the time is lost, over the day, and they have an interesting graph that we reproduce also in our guide that explains also, and this is one of the things that brought us also to our project. That was exactly this: how sorry about this. How maybe teaching in the wrong hours of the day, as I've been also recently put in a paper we published in RASE on the wrong hours in the school. If we are deviate from the right hours when we bring the kids to school and they go too early, then they are too sleepy, and then the time is less productive. And I would like to know whether, because I'm pretty sure I haven't worked myself very much with PISA data, but they yet they don't acknowledge when the classes are taught or what time the school starts, right? In the PISA data, it's not something that it's paradoxical, because the OECD was the one who made this report saying when do you teach is very important, and then when they do the tests on the PISA, they don't reflect these variables. You don't know when students are getting these lessons, right?
Yeah, I agree with you that would be very interesting. No, I think at the moment, the OCD hasn't reported this timing at the moment in any of the I think 5 cycles of PISA. And it's what you say. Why are you using this in a report and not in PISA? That could be very interesting. And I agree with you that yes, it also happens here in Spain. Students start very early school, maybe at 8 or something like that, and then they finish, I don't know, maybe 5:30 or 6:30. So yes, this is what I think. This is what you are saying. There are many hours, which could be more unproductive because students are tired. So I agree that could be very interesting, and no, PISA doesn't report it, but it would be very useful. Yes.
I mean, tomorrow we have also a presentation from Denmark. I think when I did the study myself, what we found is that in Denmark also they have very long days. They have one of the longest instruction times in Europe, I think higher than Spain. But on the other hand, we have, for example, Finland, and Finland or even Estonia are countries which have much less instruction time, and also there are countries which have them much more progressively. Well, as the kid is older, then they start getting more hours. But ours is very flat. All primary education is the same hours. Then they go to secondary education and then have again flat distribution of hours. And yeah, this maximum, what they say, this less is more, this is what the Finnish say, and this is very much what is, I think, in the background of your paper, like it's better rather, we should consider why, if we do more hours, we don't get better achievement, and if maybe it's better to move to less and get it in the right time, So it becomes more productive than to have a lot of time and lose it, no, here and there. No? And this is something that we are also very much interested on. So
Yes,
thank you.
that's the problem. We have a lot of time, but maybe if PISA assessed content-based knowledge, we will get very good results because students will be very good solving this kind of problem. So if the RCD said, okay, these are the type problems that you are going to receive in your PISA test, and students are prepared to that, maybe we will perform as the
Yeah,
best. But the problem is that
the,
we are not, PISA is not
uh,
measuring that.
although I had my doubts, because many studies, what they say is that this is very short memory frame also, but especially when they do studies, for example, on this PAU, no, this access to the university exams.
Mhm.
People has
Yes,
to remember many things, do exams in very short period of time. 1 month after, they basically have forgotten most of it because it's
I
not.
agree. I totally
You
agree.
have you have to integrate the knowledge, so to being able to use it and to rescue it later. So it has to be cannot be just facts. There cannot be just factual knowledge. Yeah. Okay, so anybody from the audience would like to make some question? Let me check the chat. So feel free also to open the micro and the camera. I think it's nice. We are a few people. We can share the video also. I think it's a bit more interactive. Luis, one more question. Did you account for hours outside the school for extracurricular, like reinforcement classes on maths or what the students do? This PISA is because I think in PISA there is some type of data about that. No, the students are doing more extra hours, and if so, then what is the effect of whether you have been controlling it also for social class, like other students who have more family background, more income in the family, they attend more these classes or?
Well, we haven't controlled by extracurricular classes because this is in another questionnaire, which is I think it's called Educational Career Questionnaire. I think it was taken only by 1/3 of the sample, and in some countries it wasn't taken. And I think that in Spain we don't have information. But regarding the socioeconomic background, we don't need to control by it because it's the same between subjects. So as we are using student fixed effects, we are controlling by this because it doesn't change so much. So much no, the change between subjects is zero. So we don't have to control it, but we are controlling by it. That's the idea. But regarding these extracurricular classes, I agree that it would be very interesting, and we also have reading and mathematics, so we could use also student fixed effects with this extracurricular. But the data is not prepared in the case of Spain to do that. As for instance, this will instruction time, which is prepared to be done.